Hello everyone, in this video I'm going to discuss the topic differentiation. So given the function y is equals to u squared minus 1 over u squared plus 1 and u is equals to square root of x squared plus 2. First, find the dy dx, then evaluate the value of second derivative at x is equals to 0. So at first, I'm going to use the chain rule where we have dy dx is equals to dy du multiply with du dx. So now I'm going to differentiate the function y. So before we differentiate, my suggestion is I'm going to have the long division, make it become proper fractions. So u squared minus 1 divided by u squared plus 1. So 1 will be u squared plus 1 and we will have negative 2 as a remainder. So now we have y is equals to 1 minus 2 over u squared plus 1. Kindly rearrange the situation so that it is easy for us to differentiate. So where we will have y is equals to 1 minus 2 bracket u squared plus 1 to the power of negative 1. So now we are going to differentiate y respect to u. So dy du will be equals to, differentiate 1 will have 0, followed by 2 bracket u squared plus 1 power of negative 2. Differentiate u squared plus 1 and we will have 2u plus 0. So finally, dy du is equals to 4u over u squared plus 1 to the power of 2. So here is the first part, dy du. So next part we are going to focus on the u. So u will be equals to x squared plus 2 to the power of 1 over 2. So next we are going to differentiate du dx, where we will have 1 over 2 x squared plus 2 to the power of negative 1 over 2. Differentiate the x squared plus 2 and we will have 2x plus 0. Next, simplify the situation. So where we will have du dx will be equals to x over square root of x squared plus 2. So next we are going to multiply both of them, or we are going to substitute into the chain rule formula. So we will have dy dx will be equals to dy du, where we have 4u over u squared plus 1 power of 2 multiply with x over square root of x squared plus 2. So do remember, u actually is equals to square root of x squared plus 2. So in here we will have dy dx equals to 4 square root of x squared plus 2 over square root of x squared plus 2 bracket square plus 1. Then we have square multiply with x over square root of x squared plus 2. So now we can simplify the situation. So we will have dy dx equals to 4x over, if we simplify the situation, we will have x squared plus 2 plus with 1. So bracket square. So if we simplify the square root with the square, we will have x squared plus 2. So finally, dy dx will be equals to 4x over x square plus 3 bracket square. Before we further our discussion, let's us define or determine the value of dy dx. So if we substitute the value x is equals to 0, dy dx will be equals to 0 over 3, which is equals to 0. So previously we already defined or determined the value of dy dx and also the derivative for dy dx equals to 4x over x squared plus 3 power of 2. So my suggestion would be, in order to find the second derivative, I'm going to cross multiply x squared plus 3 to the power of 2 in order to avoid the quotient rule. So we will have x squared plus 3 to the power of 2 multiplied with dy dx equals to 4x. Next, I'm going to differentiate for the second time in order to have the second derivative. So let x squared plus 3 squared as a u, dy dx as a v. So now I'm going to differentiate. So where we will have dy dx. Differentiate the situation. So we will have 2 bracket x squared plus 3 to the power of 1 multiply with the differentiation of x squared plus 3, and we will have 2x plus next we're going to copy x squared plus 3 power of 2. Differentiate the v, we will have second derivative, which will be the equals to 4. So now what we have to do is to substitute the value when x is equals to 0 and the first derivative will be equals to 0 into the function. So we will have 0 multiply with all these things will become 0. Continue. We will have 0 square plus 3 bracket square for the second derivative, which is equals to 4. So we will have second derivative equals to 4 over 9.